banana guards. So what we've got here is a relative velocity problem. So how your velocity and someone else's velocity kind of look against each other. And what we have here is a vehicle speeding at 115 kilometers per hour on a straight highway, when a police car moving at 145 kilometers per hour enters the highway from an on-ramp and starts chasing it. Okay? The speeder is 175 meters ahead of the police car when the chase starts, and both cars maintain their speed. How much time, in seconds, elapses until the police car overtakes the speeder? Let's do this. Let's not do this problem in seconds. Let's just do it in hours first and then convert to seconds. Okay? Maybe it'll make things a little bit easier to begin with. And let's draw a picture because pictures are super helpful. So here's our road. Here's an on-ramp or something, right? That's a poorly drawn on-ramp, but whatever. So here's the cop car. And here is the speeder, right? And we were given in the problem that there is 175 meters between them, okay? That is the distance the cop has to close on the speeder, okay? What we need to think about here is how much speed or how much faster is the cop moving than the speeder. We know the speeder is moving at 115 kilometers per hour, and we know the cop is going at 145 kilometers per hour. If they were going the same speed here, then the cop would never gain any distance. They would be like a relative velocity of 0. But since the cop is going faster than the speeder, what we can think about here is the speeder really isn't moving, but the cop is going 30 kilometers per hour faster than them. This is their relative velocity. This is the rate at which they're going to gain. Okay? So if they're moving 30 kilometers per hour faster and they need to cover 175 meters, which, let's convert this to kilometers real quick. This is 0.175 kilometers. There's 1,000 meters in a kilometer, so 1, 2, 3 for the 3 zeros. So if I need to close this down in some amount of time, time, we remember, is equal to a displacement divided by a velocity. That's just rearranging the velocity equation. And the distance they're traveling is 0.175 kilometers. And the velocity relative is 30 kilometers per hour. If we do this, our kilometers are going to divide out, which is nice. It will give us an answer in hours, which we're going to have to convert. That's okay. But 0.175 divided by 30 is 0.0058 hours. And if we need to convert that into seconds, well, we know within 1 hour of time, there are 3,600 seconds. So we'll just multiply this by 3,600, which gives us 21 seconds. So it'll take about 21 seconds in order for that cop to catch up to the speeder, assuming neither of them hit their gas or hit their brakes and they just constantly move. Okay, and we have to have that constant velocity to use this equation, but in doing so in some relative velocities, we were able to figure this out pretty easily. So not too crazy of a problem, just took a little bit of thinking about how one car is going to move with respect to the other, how much faster that is. If this car we can think about being stationary, then how much is the cop going to achieve on it? And then with a little bit of unit conversions, we've finished out. And with that, this problem's over. Take it easy. Adios. See you on the next one.